Hello, Matthews. Gatos here. Really popular question, page 325, number 4. Let's get started. So points A and B lie on a circle O with a radius of 5. Find the value of AOB that produces a maximum area. Okay, let's draw a little sketch. So here I've got my center of the circle, and then just pick any points A and B on the circle, and then we're just going to make a triangle. So connect the dots. Not perfect, but that's okay. So I want to find a maximum area. I want to find this angle here that has a maximum area. These, of course, are 5 and 5. So what I'm going to do is I'm going to take that triangle off to the side just so I can write on it. So this is my triangle AOB. Now, I know this is ultimately the angle that I want to find, but I'm going to use a different angle to start with. So I'm going to, from the apex of my triangle, drop down an altitude, which is the height of my triangle. And I know that that altitude splits the base into 2 equal pieces, and this is 5. So I'm going to actually use this angle here, I'll call it angle X, to differentiate from the angle theta, which we're ultimately trying to find. Okay? And then I will call this the base, just this little half. But I know that that's not the whole base of the entire triangle. Okay, it's just half. So because it's an isosceles triangle, it splits that big base from A to B in half. So let's come up with an expression for base and height in terms of my angle. So let's look at angle X. If I look at angle X and I do the sine of angle X, that's opposite, which is height, over hypotenuse, which is 5. Multiply both sides by 5, and I get that 5 times sine x is equal to the height. Let's do the same thing for cosine. So cosine of x is adjacent, which is base, over hypotenuse, which is 5. Again, multiply both sides by 5, and I get 5 cos x equals to the base. Now, remember that base is only half of the base. So this is kind of like a base, and this is the same base. All together, you would get your big base of the triangle. So because that is only half, I know that my entire base would be 2 of those. So 5 cos x plus 5 cos x is 10 cos x. Okay, now let's go to area of a triangle. So area of a triangle is base times height divided by 2. I know that my base is 10 cos x, and I'm going to multiply that by height, which is 5 sine x, all divided by 2. So 10 times 5 is 50. 50 divided by 2 is 25. 25 cos x sine x. Okay, so now I'm ready to do the derivative. Now remember what I said to you, if you can make your function simpler, you make your derivative simpler. So you could do the derivative here using product rule, but I'm going to borrow from trig, my trig identities. I know that sine of 2x is equal to 2 sine x cos x. So I'm actually going to rewrite this area as 12.5 times 2 sine x cos x. And then I can just use my double angle identity. So the area is going to be 12.5 times sine of 2x. Okay, so let's do the first derivative. So it's going to be 12.5 times the derivative of sine is cosine. And then I have a little chain rule because it's not just x, it's 2x, and the derivative of 2x is 2. So that means that my first derivative is 25 cos of 2x. And I'm going to set that to 0 to find out what my critical value is. So 25 cos of 2x has to equal 0. Divide both sides by 25, and I get cos of 2x equals 0. Well, what value of cosine has a ratio of 0? Well, I know that, I'm just writing this down in brackets, I know that cos of pi over 2 equals 0. So that means that 2x has to equal to pi over 2. Divide both sides by 2, and my critical value is pi over 4. Now I need to prove that that's going to give me a maximum. So what I'm going to do is I am going to use the second derivative test. So let's find out our second derivative. So it's going to be 25 times the derivative of cosine is sine, but because it's a c function, it's negative sine multiplied by 25. So my second derivative is negative 50 sine of 2x. So let's plug our critical value in and just see if our second derivative will be positive or negative. So negative 50 sine of 2 times pi over 4. So that means my second derivative is negative 50 sine of, this is going to be pi over 2. Now I know that sine of pi over 2 is 1, so 1 times negative 50 is negative 50. So my second derivative is negative, which means that my function is concave down, and I know if I'm concave down, I do in fact have a max. So I have proven that pi over 4 will yield a maximum. Okay, now let's make this bigger. Look at all the work that we've done here. It asks us to find angle AOB. We just found angle X. So remember, angle X was our base angle. So let me just go back down here, and we're going to draw the triangle a little bit bigger down here where I have more room. Oops, a daisy. There we go. So what we just found, we had AOB. We just found out that this angle is pi over 4, and because it's an isosceles triangle, this is also pi over 4, but this is the angle that I really wanted. Now remember, angles in a triangle add up to 180 degrees. So if I have pi over 4, which is really 45 degrees, plus I have 45 degrees, I have to do 45 plus 45 plus theta is equal to 180. So therefore I know theta has to be 90 degrees, but we like it in radians. So we'll say it is pi over 2. So if theta was pi over 2, that would give me a maximum area. So altogether, find the value of AOB that produces a maximum area. The angle is pi over 2.